Right, thought I'd do a little look at this inverter after I'd take it apart to add a little modification, and I discovered how terrible it is. That's not true. It's a Mercury 1000 watt pure sine inverter, also sold under the Sealy brand, and I quite liked it. I thought it was really definitely does the what it says on the tin. I've not had any problems, but I was going to add a remote switch with a timer, so that a particular device I could have it ignition triggered, and it would at least stay on long enough for the device to boot, so that you know, I don't have a thing come on for 30 seconds and then go off again. But let's here you go. Interesting construction, because the top two pins on each side here separate this top shell. All of your diodes and the output FETs, input FETs there, and I had well, there's a few peculiar things about it. Firstly, there's this piece of crudely fabricated plastic in between the input and output stage, which I guess does wonders for the airflow. Perhaps that's to push the airflow towards the FETs, but certainly not a good design. What I was planning to do was just add a little relay in the front, perhaps on that bit of heatsink there, to try and avoid the interrupting the airflow too much. Anything else, the fan doesn't come on a great deal. But then I noticed a few fantastic things. It's fused down here. Each transformer has two 30 amp fuses. Relatively small, 2200 microfarad input capacitors, 16 volts, which is barely enough. And the reservoir capacitors there, two in series, 250 volts each, which is sufficient. Although it's the second device recently I've seen that's got two lower voltage caps in series. The previous one was 200 volts, so I guess this is better at least. I'm not sure why it doesn't have a single cap with with a 400 volt, 500 volt rating. Maybe that's harder to fit in the case. And the other thing, we'll stay on these capacitors, because this one is fine, and this one is not actually soldered in at all. If you can see that there, and I can actually, well, yeah. I can move it up and down, side to side. It's clearly not soldered in, and I suspect the reason why the device was working was that this piece of plastic was just holding it in such a way that it made contact. And again, this rather heavy inductor, it's got a cable tie to hold it down, but quite frankly, any kind of vibration in that thing is going to fall out. So unfortunately, I'm going to have to strip the whole thing down, which is a pain, because all of the FETs have to come out, and various earth straps and such. and yeah, resolder this, perhaps get some make sure it's flush with the circuit board, and perhaps put a bit of caulking, a bit of glue on there. Same with this one. I'll probably just make sure it's held firmly to the circuit board with a bit of hot glue there. I need to have a look at these capacitors, because if this is supposed to go up to 15.5 volts, those 16 volt capacitors are really not sufficient, but they're in pairs, so I wonder if those are in series as well. As I say, this inverter really is, well, I've certainly had 900 watts out of it for a reasonable period of time for a 1000 watt inverter. It's certainly sufficient. I haven't tried overloading it or anything. Fuses are at least in sockets, not soldered to the board, which is nice. And it's quite compact. It's one of the smallest ones I've seen. But I guess the modification I want to do does actually require direct access to the power. So if I have to take it apart, then it'll give me an opportunity to cable it a bit properly, rather than just sneaking another connection to those binding posts. But well, I shall take this apart, and we'll I'll see you in a bit. Okay, well, that capacitor is completely dry, not attached at all, as we suspected. Lots of solder here. That's fine, making up. It's actually holding on some quite substantial extra copper wires that are embedded in the solder for some areas. Interestingly, here, this inductor that's not strapped down, the wires come through the holes and make up pretty much most of this this track. Is those wires embedded in the solder on the track, and this one as well. I was concerned about that when I looked at it from the top, because it looked like it was also a dry joint, but I'm not sure. Certainly, the wire certainly goes through and into there quite substantially. I'm still going to strap it down in some more sensible fashion, though. Anyway, as you can see, one inductor with one inverter with no chassis on it. I'm just going to get that thing soldered in properly, and anyway, I'll get that soldered in properly, and we'll move on. Right. Well, we've resoldered this capacitor. With hot glue to hold it down, and sort of mount them a bit more firmly. I put a massive lump of glue on that inductor, because I'm planning to mount this thing in a vehicle, and just having that floating around is just not acceptable. It would break off. If you notice here, I've attached a couple of wires to one of the fuses for the remote that I'm going to do shortly. But I'm just going to make sure I haven't injured it in any way, before we proceed to put it back in the box. So all of the heatsink pads are clean, so when I put it back in there won't be any. Be careful actually, because the desk here obviously tends to get a bit of abuse. It's nice and substantial. I've had engines sitting on this, so I might get a mat. I don't know if you see, I put a bit of paper under there just to make sure I didn't get any bits of metal that could puncture these insulation when I put it back on. And I'll probably just put a bit of grease in between them. I don't have any regular heat transfer compound at the moment, but to be honest, anything that's going to improve that a little bit will be a benefit. So I'm just going to make sure the switch is on, and okay, we appear to, yeah, we appear to have a green light. My proper voltmeter is indoors, but this one should suffice. You see volts. I'm assuming I'm going to have to pull off the guards on this to get to the live and neutral pins on that, and that one's 232 volts, so absolutely fine. Pull that one off. While I'm here, actually, I might see how much current it draws at idle, just as a interesting aside. Oh well, I didn't really intend for that to fall off, but never mind. So I assume you can see that there. Okay, so see, that's not terribly good, is it? Really, let's be honest. Yeah, that's 1.5 amps. Okay, well, I have to worry about that one later. Not a lot I can do about that, but it'll be ignition triggered anyway, so that's fine. So we're going to put that back in the box, get it all screwed back together, and then we can look at the modifications. Right, it's all back together, and I have some partially complete modifications here. This here is essentially a little timer circuit with a relay. And I've connected it to the additional power feed that I installed when I had the board out, and also it's connected to the switch. So the inverter still is working fine. You can turn it on and off with the switch, and this connector will just be glued to the front, and essentially one of these is positive power and the other one is the signal pin, and essentially the intention is to hook this to ignition in a vehicle. So I'm just going to use this probe to short the two pins out, and what will happen is you'll see the light on the relay come on. And you'll notice I've removed that now, and the inverter will stay on for about 2 minutes. The intention being that the device that's attached to the inverter in the vehicle will always get the opportunity to boot before it loses some power. because I want it to be in a stable state before before it's shut down, and that was the intention for that. It'll be a little connector on the front of the inverter. It won't make any difference to the operation for moving it around, etc. And I'm just trying to talk long enough for it to turn off, actually. But I intend to just mount it in there. See the cables routing around there. I've reassembled it with this guard in there. I'm really not sure what the purpose of that is, but I'll put it back anyway. And these, as you can see now, are absolutely rock solid. That's not moving. Irony that the quality control sticker is on the component that wasn't soldered in. Yeah, that's not. I can move the entire device with that now, so that's fine. These ones, there's some down here that are actually got a reasonable amount of caulking around them, and that's this reassembled. I just need to place the lid back on the top, and I use just a little bit of automotive grease for heat transfer on the yeah, you can see it's turned off now. On the FETs, completely unnecessary really. They've got the pads, but anything you can use to increase the heat transfer is better than nothing. Job done. I'll just get ready to attach that. I'm not going to be terribly pretty. It's just a matter of getting it in that space and wedge it in with a bit of glue, and that'll be fine. It's just this rubberized stuff. It will come off if I need to remove it, and then this connector can just be glued on the front, facing down out of the way of the vents, so that I can plug it in when it needs to be in the vehicle. Job done. I guess I'll show you a picture when it's fully assembled. Alright, there it is, pretty much completed. The switch wires come around from here, and the connector on the front, which is secured. These wires are probably fine. There's a bit of 3D printing with hot glue on the back there, just to make sure that this doesn't vibrate loose, because it's quite tall off the circuit board. That will just pull off if I needed to get it out, but it's quite. It won't vibrate at all. I think that's fine. So now we have nice secured inductors. And these are soldered on properly. Bit more heat transfer, and it's probably time to put the lid on. Where does that go? I think it was this way. And there we go. Just add the screws, and we'll be done. Thanks for watching.